Okay, welcome to part 2 of section 1 of chapter 8, where polynomials are still our main topic. I'm going to skim through this review and let you do the review on your own. In this half of section 1, we're going to concentrate on adding and subtracting polynomials. Two things to keep in mind. First, we want to rewrite the polynomial in standard form. And second, remember that you're basically combining like terms. When you combine like terms, you add the coefficients. So we're going to combine like terms. Also, don't forget that the sign travels with the term. So we're going to rewrite in standard form, then we're going to concentrate on combining like terms, and we're going to realize that our sign stays with our term. So 7y squared plus 2y minus 3 is already in standard form. So I need to rewrite the second polynomial in standard form, so the greatest power goes first. Then negative 4y stays where it was, and I'll take the constant of 2 to the end. So now if I rewrite with my like terms together, I'm adding this polynomial, it's being added to this polynomial. So 7y squared is like 5y squared, so there's like terms. Then we have 2y, and it's a negative 4y, the sign stays with the term. We're ready to add those two together. And then the negative stays with the 3. So if you want to say it's plus negative 3 plus 2. So now I add 7 and 5 and makes 12y squared plus 2y minus 4y is negative 2y. And plus negative 3 plus 2 is negative 1. So it's nice to rewrite that 12y squared minus 2y minus 1. Since we are in Algebra 1, we know that plus a negative is negative. So that would be your final answer. That's how you would work it out horizontally. Let me show you how to work it out vertically. Some of you may prefer that. Again, we're going to rewrite to standard form. So the first term was already in standard form. When we rearrange the second polynomial, this is what it looks like. We remember this from elimination of equations. Look very similar. 7y squared and 5y squared makes 12y squared. Notice we're working vertically here. Positive 2 minus 4 leaves us with negative 2y, and negative 3 plus 2 is a negative 1. So that's how it looks vertically. Most of the time I'll do mine horizontally, but you absolutely can choose which way to work them. Okay, again, the first term stays like it is. The second term needs some work. Negative 7x squared becomes the first term. The negative stays with the 7. The 3x is positive, the negative stays with the 9. Now we can combine like terms. We're ready to add those. Negative 2x plus 3x, ready to add those. And 7 minus 9. So that's going to give us a negative 3x squared plus 1x minus 2 will be our final answer. And if you wanted to see how that looks vertically, same answer. All right, let's see how you do with number 3. On our second page, we're going to be subtracting polynomials. Remember that there's really no such thing as subtraction. You're really adding a negative or adding the opposite, also known as the additive inverse. basically, we're going to end up multiplying every term by -1. That's the bottom line right here. To subtract polynomials, you're going to multiply every term in the second polynomial by -1. So you can again do it horizontally or vertically. I told you I typically do these horizontally. That's just the way I'm most comfortable. So let's practice what this means by multiplying every term by -1. If there is a negative in front of the parentheses, that's the same thing as having a -1 in front of your parentheses. So everything inside the parentheses gets multiplied by the -1. You're distributing the negative. So it's -3x squared minus 2x, and negative times negative makes +6. So if you keep that in mind as we look at our first example, we can rewrite in standard form. I'm debating which one to do first. Let's go ahead and take care of our negative. Let's leave everything like it is for just a second. And let's first take care of this negative. That's what's going to throw everybody off. We're subtracting the two polynomials. So I first need to distribute my negative to everything inside parentheses. So now it's just like saying we're really adding the negative, the additive inverse. So here we go. -9y to the fourth. Negative times negative is +7y. Negative times positive is -2y squared. Now, this is exactly like the problems on the page before. We need to write it in standard form. And if you liked doing it vertically, you absolutely can. We already have our y to the fourth first, but I need to bring my 2y squared to be next. And now sometimes I will go around and just highlight my different terms that go together. You can, put a circle around them. However you want to put a triangle. So instead of rewriting the problem, you can go through gathering your like terms. And 8y to the fourth minus 9y to the fourth is a -1y to the fourth. And we don't write the 1, we'll just say negative y to the fourth. Positive 6y squared minus 2y squared leaves us with positive 4y squared. Negative 5y plus 7y leaves us with plus 2y. And that would be your final answer. All right, the second one, I'll work it out too and leave you the third one to try on your own. So 6n squared plus 11n to the third plus 2n stays where it is for a second, and distribute that negative, becomes plus -4n plus 3 minus 5n squared. Now I'm ready to rearrange. 11n to the third should be written first in standard form, plus 6n squared plus 2n, plus here I should have my -5n squared, so I guess we could leave it plus and leave our parentheses. Where did everything go? So if I leave my parentheses and rearrange, I can still have a plus sign. -5n squared minus 4n plus 3. And when we start combining like terms, you'll notice that 11n to the third does not have a term like it, so I'm going to leave it. So we'll leave 11n to the third. And then we have positive 6n squared, -5n squared. We have positive 2n, -4n. And then poor little constant 3 is all alone. So just like our 11 n to the third doesn't have any like terms to combine. 6n squared minus 5n squared leaves us with a positive n squared. Positive 2n minus 4n is -2n, and the 3 is also left. constant. There you have it. You try number 3. Now let's look at a real world example. The profit a business makes is found by subtracting the cost to produce an item, which is this long polynomial, from the amount earned in sales, which is another polynomial. So let's listen to that again. Profit is found by subtracting cost from sales. So it's going to be the S polynomial minus C. The profit a business makes is found by subtracting the cost from the amount earned in sales. So the first thing they're going to ask us to do is to find an equation that will model the profit. And again, profit is cost from sales. So let's write our sales polynomial. 150x squared plus 450x plus 200. That's our first polynomial, minus the cost to produce the item. So it's 100x squared plus 500x minus 300. And to simplify, we would need to distribute our negative. So it's 150x squared plus 450x plus 200 minus 100x squared minus 500x plus, that's supposed to be a 300, it didn't show up. Negative times negative makes positive. So if you wanted to say a plus sign here and keep that in parentheses, you certainly can. And now we're ready to combine our like terms. So 150x squared minus 100 is 50x squared. 450 minus 500 is a negative 50x. And 200 plus 300 is positive 500. All right. Use this equation, and look right there. That tells us that we did it correctly because there it is, our equation. Use this equation to predict the profit if 30 items are produced and sold. And it told us in the first paragraph, X is the number of items produced. So we'll have 50, and it says 30, so in place of X, 30 squared minus 50 times 30 plus 500. And when we do all of this on our calculator, you might want to check me, make sure I'm right. I think it's 44,000. 44,000 is our profit. All right, that concludes part 2. I'm sorry this was so long. I hope you have a happy day.